welcome to this class. My name is Mobani Kestin, and I'm here to take you on the subject chemistry. The theme of this lesson is chemistry and industry, and we'll be looking at the topic metals and their compounds, part 3. Now, we'll just take a quick summary of what we did in part 1 and 2 before we'll go into this lesson proper. So, in part 1 of this lesson, we talked about metals generally, okay? We said that metals are those chemical elements that get ionized by losing one or more of their valence electrons. And this makes them different from non-metals, which actually get ionized by gaining one or two valence electrons from other elements. Then we looked at the general properties of metals. We looked at the compounds they form with other elements. And we also looked at how the general principles of extraction. We said that there are 3 general principles, which are concentration of ores, roasting in air, and reduction of the ores. And this reduction also has 3 kinds. We have reduction with carbon or carbon dioxide. We have thermal reduction, and we have electrolytic reduction. That we did in metals and their compounds part 1. Then in part 2, we went into the first group, which are the alkali metals on the periodic table. We looked at their general properties and we zeroed in on sodium as a member of this group. We looked at its extraction and uses. So I will encourage you to look at those lessons. Now, for this lesson, we'll be talking about the alkaline earth metals. And by the end of this lesson, you should be able to state the properties of alkaline earth metals, state the properties of calcium, because we'll be looking at calcium specifically as a member of this group. You should also be able to describe the extraction of calcium, identify some of its compound, and identify some of the uses of calcium. Now, what are alkaline earth metals? These metals are the group 2 elements on the periodic table, okay? So, they are beryllium, magnesium, calcium, strontium, barium, and radium. And we have some of them shown here in this diagram. Now, they are so called, the name alkaline metals. They derived this name because they form basic or alkaline oxides with oxygen. So when they react with oxygen, for example, we have calcium reacting with oxygen to give calcium oxide. This is what we call a basic oxide, all right? So whether calcium or magnesium, okay, whichever one reacts with oxygen, we are going to be having a basic oxide. So for magnesium, we will still have magnesium oxide. With beryllium, it will be beryllium oxide, so on and so forth. Now let us look at the general properties of alkaline earth metals. These metals are shiny, with silvery white color, as you can see. These metals, calcium, beryllium, they are all shiny and they have a silvery white color. They are very reactive metals, okay? And because they are highly reactive, they are not found in their pure form in nature. They are reactive. This means that they are always reacting with other elements in their environment, other materials in their environment. So you can hardly find them in their pure forms in nature. These metals also have low ionization energy. Although their ionization energy is not as low as the alkali metals, but it's quite low compared to other elements of maybe the transition metals. They have low ionization energy, and this is why they can easily give off their valence electrons. They have relatively low densities, of course, compared to other metals. Their densities are quite low. They also have relatively low boiling and melting points. They have 2 valence electrons in their outermost shell. Alkaline metals have just 1 valence electron, okay? And they are the group 1 elements. These are the group 2 elements. They have 2 valence electrons in their outermost shell. And it is with these 2 valence electrons that they use in chemical combination, in combining with other elements. And because they use these 2 valence electrons, we say that they have a +2 charge, all right? They form basic oxides with oxygen, as we saw in the previous slide. They form basic oxides with oxygen. So calcium reacting with oxygen will give us calcium oxide. This is a basic oxide. And they also react vigorously with water to give their hydroxides. So calcium will also react with 2 molecules of water to give calcium oxide and hydrogen. Okay? Magnesium as well, which is also a member of this group. Okay? Any member of the group we pick here would give the same result with water. All right? So magnesium will also give us magnesium hydroxide. All right? So they form hydroxides with water and form oxides with oxygen. They are malleable and ductile, just as every other metal. Okay? Metals generally are malleable and ductile, so alkaline metals are no exceptions. They form ionic compounds with non-metals. Their reactivity and atomic size increase down the group. So as we go down the group from beryllium to the last element in this group, we'll see that their atomic size will be increasing because, of course, atomic number is increasing, right? Number of proton is increasing, number of electron is increasing as we go from up to down. So it means that we'll have the smallest at the top, and then as we go down, we'll have the elements with the highest or the largest atomic size. So the atomic size increases down the group, and their reactivity also increases as they go down the group. Now, we'll be talking about calcium as a member of this group. Calcium, of course, is a member of the alkaline earth metals, and it has a symbol Ca with capital C and small letter A. It has an atomic number of 20, represented here, and it has an atomic mass of 40.078. It is the 5th most abundant element by mass in the Earth crust. Now, this calcium is a highly reactive element, and so it does not occur freely in nature. All right? So this means that it is mainly found in combined forms with other elements and compounds and impurities. And for this reason, it has to be what? Extracted. Okay? For us to get pure calcium, it needs to be extracted from the compounds in which it is found. But before we look at the extraction of calcium, we'll be looking at some of its properties. So, calcium is a silvery gray solid, and it has a relative density of 1.55. It is malleable and ductile, just as you see in other elements. It's a good conductor of heat and electricity. It has a melting point of 842 degrees Celsius and a boiling point of 1,484 degrees Celsius. Now, calcium tarnishes rapidly when it is exposed to air, as it forms a white film of calcium oxide. So remember our equation, calcium reacting with oxygen in air actually. So when we say it tarnishes when exposed to air, we actually mean when it is exposed to the oxygen in air, okay? So it reacts with this oxygen to give us this calcium oxide, otherwise known as quicklime, okay? So this forms on the surface of the metal when it is exposed to air. Now, calcium reacts with water to form calcium hydroxide and hydrogen. As we said, it's a general property of these alkaline earth metals, okay? They form hydroxides with water, all right? So calcium reacts with water. As you can see in this equation, calcium with 2 molecules of water gives us calcium hydroxide. It forms different ionic compounds on heating with non-metals, okay? Alkaline earth metals generally form ionic compounds with non-metals, so calcium is no exception. As you can see in these examples, we have calcium, which is a metal, reacting with nitrogen, a non-metal, and we have calcium nitride, all right? This is an ionic compound. Calcium and chlorine reacting to form calcium chloride. We also have calcium reacting with hydrogen to form calcium hydride. These are all ionic compounds. We'll be looking at the extraction of calcium. All right, so we say that calcium, as you can see, alkaline earth metals are very reactive metals, so calcium is no exception. It's a very reactive metal, okay? And it is extracted by electrolysis, or otherwise what we call electrolytic reduction. Of course, we see that calcium is one of the metals on this reactivity table that are graded under very reactive metals. So these metals are mainly extracted by electrolysis, all right? And electrolysis simply means the use of electric current to drive a non-spontaneous chemical reaction. In other words, we are using electricity to drive a reaction that on its own wouldn't be able to proceed, all right? So now the electrolytic cell for the extraction of various metals differ. For example, the electrolytic cell that will be used for the extraction of calcium, okay, will be different from the electrolytic cell for the extraction of, say, sodium or potassium, okay? The contents, the electrodes, and the electrolytes will all be different for the different metals. So, for calcium, its electrolytic cell would comprise the anode, which is what? Graphite or carbon. We know that electrolytic cells are made up of two components, which are the electrolytes and the electrodes. The electrodes are actually the positive and the negative electrodes. So here, the anode is the positive electrode, okay? And for extraction of calcium, it's going to be what? Graphite. The negative electrode here, which is the cathode, is going to be what? An iron rod. So we have here our iron rod, which is our cathode, all right? And we have our graphite or carbon rod, which is the anode, okay? The positive electrode. Now, our electrolyte is going to be what? A mixture of anhydrous calcium chloride and calcium fluoride placed on a large crucible, as we can see on the diagram. And then we're going to be having our power supply connecting the positive and the negative electrodes, all right? Now, this calcium fluoride is actually part of the electrolyte. Remember, we said that the electrolyte is made up of anhydrous calcium chloride and calcium fluoride. The calcium fluoride was added into this mixture so that it will be able to lower the melting point of calcium chloride from 842 degrees Celsius to about 650 degrees Celsius. When we talked about metals, we mentioned that extraction or reduction by electrolysis is quite expensive. So it's important that the melting point of the crude form or the compound from which the metal will be extracted should be reduced, okay? So the calcium fluoride was added to this compound, calcium chloride, to reduce the melting point from 842 degrees Celsius to 650 degrees Celsius. Now, as electrolysis progresses, okay, what happens is that there is a dissociation or ionization of the compound into their what? Ions. So we are going to be having calcium ion and chlorine ion, okay? Now, the calcium ion, of course, is positive. So it goes straight to what? The negative electrode, okay? Where it receives electrons to be turned into the calcium metal. So that's why we say that the calcium metal collects at the lower end of the iron rod, which is actually the cathode, okay, on the surface of the electrolyte. So this is where our calcium collects, at the lower end of this iron rod on the surface of the electrolyte. Now remember, we said that this iron rod should be made in such a way that it should be gradually raised. Okay? This iron rod should be gradually raised in order to accommodate the metal as it is being formed. So this is where our metal forms. Okay? So the more it increases, the iron rod should be raised up so that we can accommodate the calcium metal being formed. So that is where calcium is deposited, at the cathode. For the chlorine gas is liberated at the anode. All right? So with this, we have our pure calcium metal, and that is simply how the electrolytic process for the extraction of calcium is carried out. We'll see the chemistry of the reaction. At the cathode, there is a reduction, okay, of the calcium ion to calcium metal. So we are saying that there is that process, that reaction is actually a reduction reaction where there is what? An intake of electrons. Remember, it is the calcium ion that goes to the cathode. That calcium ion simply means that what? There has been what? A shortage of 2 electrons. So at the cathode, the calcium ion receives those electrons back to form the calcium metal. So that process is a reduction process at the cathode. But at the anode, there is what? Oxidation of the chlorine ions to what? Chlorine gas. All right, so the chlorine forms the chlorine gas and it is given off. All right, so this at the anode is what? Oxidation reaction. Therefore, we'll have the overall reaction as calcium ion and chlorine ion being oxidized and reduced to what? The calcium metal and the chlorine gas. Now we are going to be looking at some compounds that calcium form with other elements. Some of them are calcium carbonates, calcium chloride, calcium nitrate, calcium sulfate, calcium oxide, and calcium hydroxide. Let us quickly take a look at each of these compounds and how they are formed. Now, calcium carbonate. Calcium carbonate actually occurs naturally in the form of chalk, marble, and limestone. Of course, it forms in rocks as what we call stalactites and stalagmites. You can see here in this diagram we have the stalactites and stalagmites. The calcium chloride or limestone forming from up heading downwards are called the stalactites, while the ones that form from down going upward are called what? The stalagmites. All right, so this is a natural way that calcium carbonate forms. Now, calcium carbonate is used for the following. It can be used in the production of paper and glass. It's also used in the making of cement or mortar. And of course, we know how important cement is in building. In medicine, calcium chloride serves as a dietary supplement, good for healthy bones and teeth, muscles, the nervous system, and the heart. It is also used as an antacid to relieve acid indigestions, heartburn, and stomach upsets. Now, how do we prepare calcium carbonate in the lab? We've said that naturally it occurs as limestone, chalk, and marble. But if we want to prepare it in the laboratory, we can do so by mixing sodium triacarbonate 4 and calcium chloride solutions. Okay? Calcium carbonate will form as a precipitate. So when calcium chloride reacts with sodium carbonate, calcium carbonate will form, while sodium chloride will be given off also in that reaction. So this is one way we can prepare it in the laboratory. Another way we can prepare calcium carbonate in the laboratory is by reacting calcium oxide, which is quicklime, with water. Okay? When we do that, calcium hydroxide is going to form. Now, when calcium hydroxide is formed, carbon dioxide is bubbled through that calcium hydroxide produced to now give us calcium carbonate and water. So this is the first reaction, calcium oxide and water, giving us calcium hydroxide. When carbon dioxide is bubbled through this calcium hydroxide, okay, this is the equation. We are going to be having calcium carbonate formed and water. So these two ways, we can laboratorily prepare calcium carbonate. Calcium hydroxide, which has this as its formula. Calcium hydroxide is also known as what? Slaked lime. So that's its common name. It's known as slaked lime. And it is produced by thermal decomposition of limestone using heat on limestone. Okay? So what happens is that limestone, which is actually calcium carbonate, is heated to a very high temperature, all right, at 1000 degrees Celsius to produce calcium oxide. So this limestone will dissociate into calcium oxide and CO2, all right? Now, when this happens, water is added to this calcium oxide to form calcium hydroxide, all right? So this is one way that we can prepare calcium hydroxide. Now, this calcium hydroxide, which we say, of course, is slaked lime, all right, is used for the following. It is used as cement for building. It is also used as a soil conditioner, and it is used to reduce acidity during water treatment. So people that deal with the treatment of water make use of slaked lime to reduce the acidity in water. Now, another compound of calcium is what? Calcium chloride. Now, this calcium chloride is a salt, and it occurs naturally in soil and sea water. It is prepared in the laboratory by the reaction of dilute hydrochloric acid and calcium triisocarbonate 4. So, calcium triisocarbonate 4, otherwise known as calcium carbonate, when it reacts with dilute hydrochloric acid, calcium chloride will be formed with water and carbon dioxide being given off as byproducts. Some uses of calcium chloride. Calcium chloride is used in desiccators as a drying agent for all gases, with the exception of ammonia. It is not used as a drying agent for ammonia, but for other gases, it can be used as a drying agent. Now, in the automobile industry, it is used to provide body for tires, all right? It's also used as an additive in canned foods such as tomatoes. It is used for de-icing roads, and it's also used for controlling dust on dusty roads. Next compound of calcium we'll be looking at is what? Calcium oxide, otherwise called quicklime or lime. Calcium oxide is formed by thermal decomposition of calcium triisocarbonate 4, of course, which is limestone, and it can be commercially extracted from limestone. So when we have limestone, we can extract calcium oxide from it. And we can do this by heating limestone strongly in a furnace called a lime kiln. So when limestone is heated to 900 degrees Celsius, calcium oxide is formed and carbon dioxide is given off. Of course, that is a gas, so it's given off as a byproduct. Calcium oxide, what are some of its uses? Calcium oxide is used for the following. It's used for making porcelain and glass in the glass industry, okay? It's also used as a key ingredient in the making of cement or mortar and in the preparation of bleaching powder, calcium carbide, and calcium cyanamide. Calcium oxide is also used for treating acidic soils in the process known as liming in agriculture. Next we'll be looking at is calcium sulfate. Now, calcium sulfate occurs naturally in two forms. We have the anhydrous one, that is the one that occurs in its powdery or dry form, and then we have the one that occurs with molecules of water in it. So we have the anhydrite, which is what? The normal calcium sulfate, and we have gypsum, which is calcium sulfate dihydrate. Of course, we can see that it contains 2 molecules of water. Now, calcium sulfate, of course, is the main cause of permanent hardness in water. Of course, if we learned about water, we have 2 main causes of permanent hardness. They are calcium sulfate and magnesium sulfate. All right? So, it's one of the causes of permanent hardness in water. Now, calcium sulfate can be prepared by adding a calcium salt to a solution of sodium tetraoxysulfate 6. So it comes out of this solution as a white precipitate. So when we react calcium chloride and sodium sulfate, we'll be having calcium sulfate coming out as a precipitate in this reaction. And we also have sodium chloride as a byproduct. Gypsum, of course, which is a hydrated form of calcium sulfate, is used to make plaster of Paris, otherwise called POP. And this plaster of Paris, of course, in the medical world, is used for setting bones. Okay? Gypsum is also used for making molds, cement, and wall plasters used by builders. Gypsum is also used as a blackboard chalk. Now, the anhydrous calcium sulfate, okay, the dry one that doesn't have water in it, is used in the laboratory for the production of some chemical compounds such as ammonium tetraoxysulfate 6 and tetraoxysulfate 6 acid. All right? So, the anhydrous form can be used in the lab to prepare other chemicals. Now look at calcium nitrate. Calcium nitrate is another compound of calcium, and it is prepared in the lab by the action of dilute trioxynitrate 5 acid on lime, okay, on lime or limestone. So when dilute trioxynitrate 5 acid acts on calcium oxide or on calcium carbonates, calcium nitrate will be formed. So we have here limestone reacting with trioxynitrate 5 acid, okay, to give us calcium nitrate with CO2 and water as byproduct. Now the salt formed on cooling is going to be what? A white deliquescent tetrahydrate crystal known as calcium nitrate tetrahydrate, okay? So it is going to be formed with some molecules of water. Now, another way we can prepare calcium nitrate is by the reaction of ammonium nitrate solution and calcium hydroxide. Okay? When these two react, it can yield calcium nitrate. As you can see from the reaction, ammonium nitrate and calcium hydroxide to give us what? Calcium nitrate and ammonium hydroxide as a byproduct. Now, what are some of the uses of calcium nitrate? It is used as what? Fertilizer, okay, for the growth of plants, of our crops. It is used in wastewater treatment, okay. It's also used as a coagulant in latex production. So these are some of the uses of calcium nitrate. Okay, so that's that on calcium and the compounds it forms. Now we'll be looking at some of the uses of calcium, all right? Calcium is needed in our diets, okay, for the development of strong bones and what? Teeth. So when we eat some certain foods that contain calcium, some foods such as milk, butter, eggs, cheese, these foods are rich in calcium. And we are saying that this calcium is needed in our diets for the development of strong bones and teeth, especially for young growing children. It is also used as a reducing agent in refining elements such as thorium and uranium during their chemical processes. Another use of calcium is that it is used as a getter in vacuum tubes to remove trace gases. It is used also in the making of certain alloys. For example, we have the tin calcium alloy, that is alloy formed by calcium and tin. Okay, we have the magnesium calcium alloy, which is alloy formed by calcium and magnesium. Then we also have the aluminum calcium alloys and lead calcium alloys. So this is a metal that can be combined with other metals or elements to give a different and a more valuable metal. Calcium sulfate. This is a compound of calcium. Of course, we talked about it when we looked at some compounds that calcium forms. Now, this calcium sulfate, okay, is used in making plaster of Paris, as we saw in our lesson. And this plaster of Paris is used for setting bones, okay. Calcium carbonate, which is another compound of calcium, is used in making white paints, toothpastes, antacids, cleaning powder, etc. Calcium nitrate, another compound of calcium, okay, serves as a naturally occurring fertilizer used to improve the quality and yield of crops. So with this, we have come to the end of this lesson on calcium. Let us take a quick summary. We say that the alkaline earth metals are the group 2 elements, and they are beryllium, magnesium, calcium, strontium, barium, and radium. We also say that calcium is a member of the alkaline earth metals with the symbol Ca, an atomic number of 20, and an atomic mass of 40.078. And then we say that calcium is extracted by electrolytic reduction. And we looked at some compounds of calcium. Some compounds of calcium are calcium carbonate, calcium chloride, calcium nitrate, and calcium sulfate. We also looked at some uses of calcium. We said that calcium is used as an alloying agent, a reducing agent, and an important nutrient for the development of strong bones and teeth. Now, we'll just take a quick test to help us remember what we learned in this lesson. So, which of the following is a property of alkaline earth metals? A, they have high ionization energy. B, their atomic sizes decrease down the group. C, they form ionic compounds with non-metals. Well, the correct answer here is C. Remember, in the course of our lesson, we said that alkaline earth metals form ionic compounds with non-metals. Now, in the extraction of calcium by electrolysis, the calcium metal collects at the dash A, cathode, B, anode, C, electrolytes. So if you picked B or C, that would be wrong. We say that the cathode, which is the negative electrode, is where the calcium metal is going to form, okay? It's going to what? Collect. All right, with this, we have come to the end of this lesson. Thank you for staying with me. See you again.